Hello, good morning, good afternoon, good evening. I am Eric from BIOTOPE, and we are doing this webinar live from Cali in Colombia within the COP16 context. We are located in a small hotel very near the green zone. And we have been here, the BIOTOPE team, for 4 or 5 days now, and I have to share that it's very exciting to be within the COP. We were on the blue zone, and there's a lot of people, about 12,000 people, a lot of sessions going on. It's difficult to choose where to go. And on the green zone, so this is where the public is admitted. There's a lot of NGOs, a lot of indigenous people presenting by having booths, different regions of Colombia. So it's very interesting, very fun. So today the session is about drones, using drone technology. To put a little bit of background and context, there's a lot of discussions here at COP on monitoring biodiversity, either for monitoring, getting a baseline before a project is implemented or during conservation actions. As you know, there's different technologies being used. eDNA, plane surveillance, drones, and all of those technologies are helping experts, naturalists, experts in making assessments on the state of biodiversity. So what I'll do is give a quick introduction about the different speakers, and then we'll get started. So today on the panel and the discussion, we have Mark. Mark is with a company called BioConsult in Germany. It's a company of BIOTOPE. So Mark joined BioConsult in 2019 as a scientist, and he's leading the section of nearshore and onshore drone studies within the remote sensing department. Mark has a lot of experience in planning and executing drone surveys, as well as data processing and analysis. He uses remote sensing techniques for ecological applications like bird counting or detections of beach litter. And we'll have Anna Kirsten. Anna, she's a trained ecologist, specialized in bird ecology. She's with BioConsult since 2020. She's involved in drone projects in the remote sensing department. And particularly research is related to species and habitat in the Wadden Sea. This is northern Germany. Anna performs drone operations, and she has a strong background in statistics and data analysis. And then we have Diana Carolina Romero Dacchiardi. I hope I'm pronouncing your name correctly, Diana Carolina. Diana is a topographic engineer with a specialization in GIS, with 12 years of experience using GIS and remote sensing for research in marine coastal areas of Colombia, with research institutions called INVEMAR. Additionally, she has more than 5 years of experience using drones for the monitoring of marine and coastal ecosystems. So I wish everyone a very good webinar, and let the floor now to our first speaker. Thank you so much for joining in.
Yeah, thank you a lot, Eric, for the nice introduction, and hello, everybody. My name is Mark Schnoraba, and I will start our presentations today by starting with a general overview on drones and conservation, and then we will have 3 case studies we are going to present. As Eric already introduced, I'm from a German company called BioConsult, which is located in the northern part of Germany, and which is a company focusing on ecological consulting and research. And I myself am working in the remote sensing department, where we are using satellites, aircrafts, and drones for ecological and environmental applications. But today I want to focus on the drones, and I want to start with the motivation on why we use drones. Those might vary between people, but I want to give you a small overview. So one big motivation for us by using drones is to scale up and extend existing ground-based monitoring. Like we can see here on the right side, there's a colleague of mine walking along a mussel bed in northern Germany, and with a traditional monitoring approach, he's walking once around the entire area and then across the area to determine the extent and the coverage of the mussel bed area, which you can imagine on the size of the person is quite a time-consuming approach. So we accept from drones that they can help us with a more time-efficient approach where we can cover large areas in a shorter period of time, and therefore also be able to cover larger areas. Further motivation is to unlock remote areas, particularly hard to access areas, but also sensible areas where it's difficult to be there on the ground, and which with the drones we can cover from above. Drones furthermore promise to get insights in new information, particularly in geoinformation, which can then be combined with the environmental parameters to get new insights in ecosystems and can answer different ecological or research questions. Furthermore, the drones promise to give us a reproducible data set, as most of the drone data is safe digital and therefore can be used for analysis directly at the point, but also some years later, for example, with a further development of AI. Now I want to show you the small overview of the types of drones. You can generally distinguish between two main types, the multicopters, here small, and a larger multicopter with which we can cover small to medium areas. The multicopter can always be flown manually and automatically. We have a live view and they're good for detecting or monitoring approaches. And there are the fixed wing drones, which are like small aircrafts. They have a bigger area coverage and can therefore be used ideally for monitoring and surveying purposes, with the smaller fixed wing drones for large area coverage and the bigger fixed wing drones for a very large area coverage. Those bigger drones are a bit look into the future, but will be coming soon as well. So what are the kind of applications we can use drones for? I give you a short overview of the applications we use them, starting with a wildlife monitoring. So you can make a simple count of animals. Here in the top, you can see a colony of cormorants and of spoonbills, which can be counted by the drones. Besides birds, of course, you can also look into marine mammals or land mammals like seals or deers, and we can use different kind of sensors. So here we have like the visible light sensors, the RGB sensors, but of course you can also use thermal sensors to get more insight into your data. Besides, we have the habitat monitoring, which is enabled by the drones, where we can cover large areas of, for instance, bog areas, salt marshes, mussel beds, or seagrass meadows, and those areas can be covered by the drones, and the application of machine learning approaches can enable us to make a classification of the different habitats or ecosystems. A third application we use drones for is coastal environment. I will show you one of our use cases where we looked into beach litter on Arctic beaches with drones, but also the example from Diana looking into mangroves is a good example for coastal environment. Then, because of the geoinformation we can collect with the drones, we also have another kind of applications where we can collect, for instance, information about the height or elevation. So we can create elevation models or make some 3D reconstructions. Okay, now I want to show you an example workflow on how we use the drones. So of course, there's the drone survey itself with the preparation, the drone flying, and the processing. First of all, you have to identify your area of interest. your target species, and then you have to conduct the survey. And then while we are conducting the surveys, we always have at least a second person in the field looking into the reaction of the animals. So looking into potential disturbances to be able to adapt the flight path within the field, or in the worst case, even abort a mission when we see that there's a visible disturbance of wildlife due to the drones. Once finished in the field, we are going back in the office, and a typical workflow for us looks like first processing the data, and then we have mostly in the beginning a manual task. So here, for instance, a manual identification of birds. So we detect the different bird species and then identify them on a species level. This is a lot of manual labor, but we have to do it in the beginning at least, and then can use in a second step, hopefully, AI approaches. So to use the manual results to train an AI to really unlock the potential of drones by having an approach how to deal with this large amount of data. Okay, and now I want to give you a very short overview about the legal aspects, at least about legal aspects in the European Union. So there's the question on how and what we can fly, and the how is we can fly in visual line of sight up to 120 meter without a permit with a small drone. But once we want to fly beyond visual line of sight, or we want to fly above 120 meter or use a big drone, we need special permits, which are quite time consuming. The third question, the where to use the drones, and there are the so-called geographical zones, which can limit or even prohibit the use of drones. Those geographical zones are, for example, national parks, recreational areas, infrastructure, police and military. And here we can have at least partly permits once applying to get over those limitations. So to sum up the first part of the general overview of drones, I want to point out again the benefits and the limitations, with the benefits or the potential benefits being the remote data acquisition of very large areas with high resolution data with different sensors. Those data sets are comparable due to its digital character. And another potential benefit is a potential in limiting disturbance compared to ground-based approaches. So it's always the comparison which is important here. Therefore, we also have like the potential limitations. First of all, the manual image processing in the beginning, which is very time consuming and also quite costly. And the second part is then the potential of disturbance. So it can be a potential benefit, but it can also be a limitation. And for the disturbance, it's very important to look onto your approach of which drone you are using, which flight altitude, but also the target species in the area, which can show very different reactions to the drone. And then the last potential limitation being restrictive regulations. At least here in Germany, flying the drone became a bit more complicated in the last years. So there are some limitations, but I think and I hope things will get a bit easier in the future. And with that, I want to come to a first use case I want to present, which focus a bit on the question how to develop a kind of monitoring of drones for conservation. And therefore, I want to present you two projects about beach litter monitoring in the Arctic using drones. Those two projects are are done in cooperation with several partners like Aquaecology, the DFKI, and the Kikata Communio, and they are on behalf of the German Environment Agency and the BMUV. And here again, I want to start a bit with a motivation and give a bit of a background. So litter monitoring, of course, is also done from the ground. There are different kinds of litter monitoring, and one part is the beach litter monitoring, which is quite well functioning monitoring approach, which enables to detect even small objects, to categorize them. The objects of interest for the traditional beach litter monitoring are mostly objects bigger than 2.5 centimeters. So like more or less like the cap of a bottle. Those monitorings are already done for a long time, at least partially. So we have like long time series. And of course, the conventional monitoring also enables us to clean the beaches after the monitoring. Anyhow, there are also some limitations in this approach, like different protocols around different countries. Sometimes the beaches themselves are not very accessible, and the approach, as you can imagine, are quite time-consuming because of the large spatial coverage you want to obtain. So in those two projects, we were looking into possibilities of using remote sensing to make the beach litter monitoring or to extend the traditional methods. And therefore, we started to look into all three main platforms, satellites, aircrafts, and drones, and looked under the requirements of area coverage, time saving, and comparability. And our first investigation showed quite fast that none of those platforms on their own is able to cover all those three requirements. So in our pilot study, we tried to combine satellites and drones to have the very high spatial resolution of the drone sensors, but also the area coverage of satellites. And to achieve the comparability, we want to make use of the digital character of the data by using different kinds of machine learning approaches for automatization, which then can enable a better comparability. Anyhow, as my talks today are about drones, I will focus on the drone part only, and I want to show you some insights of our first fieldwork. So we developed a method with the drones to cover those beaches, to then detect and categorize the objects, and therefore we went to Svalbard and Greenland, flying those drones over several beach environments. And here I want to give you a short overview on how those beaches look like. So those are beaches on Greenland. Here and there you can see those are like sandy beaches. Here a bit the background of the beach itself, and you can see here already like bigger colorful objects, which most probable can be detected and categorized by the drone. Anyhow, what you also can see here is that some of the objects are partially covered, like the orange box or the wood on the right image. And you can see quite a complex beach environment. So we have a sandy beach, which is quite positive in the beginning, but we also do have a lot of algae. We even have some snow coverage. We have driftwood and pebbles, which make identification or categorization very difficult. So from the pilot study, after examining the results, we saw that we could find objects, but mainly objects bigger than 10 centimeter and only a smaller part of the objects being smaller than 10 centimeter. And the main reason here is the characteristic of plastics, which can have all kind of sizes, shapes, and colors. And of course, also the quite heterogenic character of the beaches here. So what we are doing right now in our follow-up study is to focus on those limitations, and with having the first focus on detecting objects which are smaller than 10 centimeter, then we want to look into a possible automatization and also the categorization of the objects. And finally, we want to have an integration in existing procedures. And this last part here is quite important because one of the main limitations of the drones, the area coverage in the Arctic, I named in the beginning, and we want to overcome by integrating drones into existing logistics and procedures. So instead of having like one person going out with a drone to a remote place, to use people being there already, and we want to try to develop a methodology making this possible for everybody. So in the very first step here, we are looking into the drones part we are using, and want to redefine the method development. So we saw we are quite limited with the approach we started on the first step. So we are looking right now again into all the different kind of drones, so small and big multicopters and fixed wing drones, and are trying to reproduce these Arctic environments with the difficult backgrounds and the quite complex objects. And yeah, I brought you one slide on how this looks like with the different drones on the different altitudes. And you can see here already that that the objects which are here on different altitudes and from different drones can be recognized or even categorized in the very high resolution, but yeah, the possibility to detect them is getting more and more difficult the higher they are. So here we have the cap of a bottle and a rope, and you can already see that some drone flight height combinations are not very suitable. Others are more suitable but limited, and we are trying to find out which is the best combination. And the best combination does not only mean the best technical combination on which drone is the clearest. This would be definitely the big multicopter on the small altitude, but we won't also look into the area coverage, the costs of the drones, and also their sensibility to climate conditions, because we have this ultimate goal of making a lot of people being able to use those drones. So with that, I come already to the end and want to show you only briefly the next steps and also the summary on how we try to develop this kind of methods. So first of all, there's like the very technical methodology. Which drone do we use? How is the study area itself? So we are going to the Arctic again to try this sensor flight altitude combination. And then the next step is yeah, starting with a manual screening to get to an automatic approach of detecting but also categorizing those objects. And then the last part, which is in this project perhaps the most important, is the integration, where we want to work together with national authorities, with the industry like cruise operators or national industry, with research institutions and universities, and also with NGOs. And we want to make all those people, or want to give those people the possibilities to use our methods we developed in exchange with them, with our AI-based analysis tool, so more people can make use of this monitoring approach. And with that, I will hand over to Anna, and thank you a lot for your time, and I'm looking forward to the discussion in the end.
As we transition to Anna, I just want to remind you that you can send questions through the Q&A. We got one question, and we'll go through all the questions at the end, if that's okay with everyone. Thank you.
Okay, so I will continue. Thanks a lot again also for introducing us and for inviting us to tell you a bit about our drone use cases. And I will continue now with the coastal project we have in Germany, namely in the Wadden Sea. So first of all, the Wadden Sea, for anyone who's maybe not so familiar, is a coastal habitat along the North Sea in Denmark, Germany, and the Netherlands. And it's basically all these intertidal mudflats here that you can see between the mainland and these islands. And it's the, in fact, largest area of continuous intertidal mudflats in the world, and it's very strongly protected. So these are just some impressions. So you have the mudflats in the Wadden Sea, but also some different habitat structures like salt marshes that are usually at the coast directly, then the mussel beds in the mudflats, and sometimes also some sandbanks that stick out even in high tide. And the traditional monitoring approach here is first of all coordinated between the countries because it's kind of a shared responsibility because of the sharing of this habitat type. But it's also traditionally mostly ground-based. So most of the time when things are monitored in the Wadden Sea, people are going into the habitats and they take samples, they map things and so on. So basically what you can see here. This is the part of the Wadden Sea in northern Germany, right to the border with Denmark, which we work in. So because our company is also located in this area. And this I will talk more about now. So when the mudflats or other habitat structures in the Wadden Sea are monitored from the ground, you always deal with a very dynamic environment because the tidal cycle means that most of the things are submerged for a lot of hours during the day. So usually you face the challenge of having a limited time to be able to actually go there and measure things and map things. But also it's not easy always to get to the places where you want to get. And all these limitations, also that you can then only in this limited time cover only smaller areas and you can maybe not cover the whole thing, but only take some samples here and there. All these limitations we try to overcome or get a different perspective on by looking from them from above and using a drone-based approach for habitat and species mapping. And when doing this, I think Mark was already kind of introducing the main questions we have there is that we need to consider if and how drones can be used and can also improve the data for the monitorings that are already going on and what they need, which type of data, but also for us as a company, how we can exploit the full potential of the data while being time and cost efficient in the meantime. And in the next slides, I will just show you for some examples on how we do this and what we have already achieved. So we stay for now with this habitat you see here, which is the mussel beds. There are blue mussels and oysters who form these reef-like structures in the Wadden Sea. And this is an image of a mussel bed where it's already labeled by a human. And what you can see is it's a super fragmented and strongly structured habitat type. And if you have many of those images, it's really impossible for humans to do all the work and label all these things. It's very easy usually for us to see, this is a mussel and this is a mudflat area. But the actual work of extracting the information, which area is which, is quite complex. And therefore, we use AI-supported processes. So we first usually take a sample of images from a survey area and we humans label them and say, oh, this is mussel, this is detritus, and here this beige area is mudflat. And then we use these images and these labels to train an AI model. So then the AI can for us really classify the whole area that has been surveyed. And then it would, for example, look like this. So this would be the AI result telling us here we have mussels, here we have detritus, and here we have mudflats. And when we then stitch back together all these images and all these classifications, we are able to produce high resolution maps of the complete area that has been covered in the drone flight, which is pretty amazing because compared to what can be done on the ground, you really get for each location in the target area, you get information in a high resolution. You get the extent of the mussel bed. You can see if it is moving. You can see if it is extending, or maybe there's some part for impacted by erosion. And you even get like the percentage of cover with mussels for each square meter or whatever unit you choose. And then, since we do this repeatedly, we can even track the changes of the same spot over time. For example, in this mussel bed, where it's been a bit growing, definitely over these months. So this is over the course of almost a year. But then we're not only interested in classifying areas, but also in counting objects or detecting objects. And objects in this case are mostly birds. So the Wadden Sea is also an important breeding area for many bird species. And when we survey the breeding colonies, we take these images from above. And these are usually large areas. And then we have to find the birds and we have to count the birds and potentially also identify the species. And this we do in a very similar manner as before. So we have some training data that we create by humans labeling it. And then we train an AI model. And then in the end, the output we get is not only showing us where the birds are, but we can even achieve a pretty good identification that it can also tell us which birds are there, so which type of species. And all of this is with very limited disturbance to the birds, because what we saw so far is that the breeding birds are pretty good with the drones. And the traditional method would be walking through the colonies, which would be much more disturbing. However, unfortunately, that's not the case for all the birds we encounter, because if you go away from the breeding birds and you encounter the resting birds who rest, for example, when they're on migration in the high tide roosts, we have not yet really found a method to reliably survey them, because all the surveying methods, or many of them that we tried with the drones, have been causing really strong disturbance effects. So we started this by flying at just with the same parameters as for the breeding birds, and we were flying at 100 meters altitude, but the birds were really sensitive to this and were flying off. What is a bit more promising is a sideways approach. So if you keep a bit more distance sideways and you zoom into the area, you can actually get pictures like this, where you can easily count birds and even identify species. We have some people who are really good at this. However, it's not very practical, because zooming into the area means that you don't have so much control over the exact overlap of the images and so on. So that's not really practical in the long term for us. So the next step would be to increase the flight altitude of the drones. And then this is still a question if it works disturbance-wise and also from the resolution. So this is something that's still to come. And then there's not only birds and mussels in the Wadden Sea, but also marine mammals. And you've already seen a sneak peek of what we're dealing with in Mark's first presentation, because we also try to detect and count seals. So here we also take images of seals, and then we label them, create training data, and then an AI model is trained. And in the future, it will be able to detect the seals, and we will be able to assess population numbers automatically, basically, whenever we can fly a drone above them. But what you can also see is that these images have not been taken in the wild in the Wadden Sea, but these have been taken in a controlled environment, which is a fostering station, where the seal pups go and they are fostered until they can be re-released. And since we work in this very controlled environment with the support of the local team, we are also able to do more than just detecting. We are also able to measure the seals and gain even more information. So the fostering station provides us with ground truth data, which is the weight of the animal at a given point in time, and also the individual code, basically, because they each mark the individuals with a different color code. And then we take the images, from which we can either in 2D take measurements, morphometric measurements, or in 3D we can even do reconstructions of the volume and the body. And then we can later on link this together with the individual identity and the weight to gain more insights on the body condition of the animals. And then this we want to transfer at some point also to the field, once we have proven that this is working. And so these are many different use cases, and from these we have already learned quite a few things. For the first is that drones have already proven a very powerful tool for us because we could improve the data quality of the data or compared to the traditional monitoring methods, and we could also increase data quantity. And this is very exciting for us. However, especially with this increased data quantity, the potential of drones is especially great when you can implement automated workflows like object detection or area classification. However, for the extended use of drones, especially in these highly protected areas, it always has to be considered the ethical aspects, for example, of disturbance. So here we've seen one case with the resting birds where it seems to be not very ethical to use drones because you don't get good data and you are disturbing the animals a lot. However, this can be a trade-off between data quality and disturbing the animals that probably needs to be decided in every individual case if disturbance is acceptable or not. And then also, if you want to integrate the drones into monitoring schemes, it has to be considered that this is likely a very time-consuming or a long process because it has to be made sure that existing data series can be continued and the data fits together and you don't lose information in the transition of methods. And then a bit of an outlook is that we think in the future it will be relevant to cover even larger areas, especially in this very time-restricted area of the Wadden Sea, where you have only the tidal cycle and restricted timeframes. And so probably larger drones at some point will be relevant. So with this, I want to end this presentation and also from Mark's and my side say thanks a lot and feel free to contact us also afterwards.
Thank you so much, Anna. Very good presentation. The images make it very easy to understand the benefits and challenges. Okay,
Nice.
we'll transition to Diana Carolina now.
Hello, thank you for the presentation, Anna. And I'm going to present about the experience in the monitoring coastal and marine ecosystems in Colombia using drones. This one is the map of Colombia, and we can identify here the principal marine and coastal ecosystems in Colombia, in the Caribbean Sea, in the Pacific Ocean, and also in the Caribbean Insular. These areas include both the Caribbean and Pacific coast, each with unique ecosystems and biodiversity. On Caribbean coast, we can find diverse ecosystems such as mangroves, beaches, rocky shores, and more. And two of the most important mangrove complexes are found in Caribbean, in Ciénaga Grande de Santa Marta and in the Cispata Bay. And the region is also home to coral reefs and seagrass beds in Corales del Rosario and San Bernardo, and in Tayrona Park and the Seaflower Biosphere Reserve in the insular Caribbean. On the Pacific coast, there are some of the largest mangrove ecosystems, particularly in Buenaventura, Cauca, and Nariño, with additional biodiversity hotspots like Gorgona Island and Malpelo Island. These ecosystems are vital and also provide ecosystem services like carbon sequestration, coastal protection, tourism, and recreation, also play an important role in climate regulation. But these ecosystems face a lot of pressures, natural and human-induced, and it's important to monitor change in these ecosystems and implement effective conservation strategies. And using drones allow for more precise real-time data collection, and this helps for better management and protection of the ecosystem. Why drones in environmental, coastal, and marine monitoring in Colombia? Drones offer a flexible, cost-effective solution for monitoring ecosystems, providing high-resolution data and the ability to access hard-to-reach areas like mangroves, coral reefs, and chains in coastline. Their ability to capture real-time, precise information with minimal environmental disturbance, and this is ideal for tracking change in the ecosystem health. There are some examples of the drone that we use for our projects. We typically use a lot of drones, selecting the appropriate model and sensor depend of the product that we want to generate. For example, if it's mapping of is a 3D modeling or ecosystem health, we choose drones equipped with sensors like high resolution cameras or LiDAR, depend of the objective of the project. This allows us to recollect the data needed for accuracy analysis if we're monitoring coral reef, mangrove, or assessing coastal erosion. And this is a general methodology for the work for the drone-based monitoring. There are 3 important phases in the monitoring, that is field preparation, acquisition, and the data processing. In the phase 1, the file preparation, we study the potential area using satellite image and forecast to understand the acquisition field. And also we select the drone based on the objectives of the project. And we develop the flight plans considering overlap, flight altitude, and potential restriction zones. In the acquisition process, we conduct the flight plan in the field, and we check the weather, the presence of possible rain and wind velocity for the drone, and identify the takeoff and landing areas for the project zone. And we can also address the specific challenge of the area, like maybe the area could be present unique challenges such as forest density or maneuvering space for the drone. And we have here the data processing are the products that we generate with these phases that are the orthophoto mosaic that could be multispectral, and if it's multispectral, we can generate in the vegetation index that help us to assess the vegetation health, and also we can generate the land cover. And we can create a point cloud, a digital terrain model, and digital surface model, and a canopy model that is very important for the sequestration carbon projects. Also, we have here the drone data acquisition. We conduct flights to capture the high resolution image necessary for generate the outputs that we need in each project. Prior to that, we review the flight zone to analyze possible obstacles, areas for takeoff and landing, and check the equipment, batteries, and SD cards. And we also perform a flight and camera test. In one occasion, we had a problem with the connection to the drone. The connection was lost for a few minutes during the autonomous flight plan, and we lost visibility to the density of the forest. We have to move closer to the drone to reestablish the connection. After that, we didn't let the drone get outside and maintain the line of visibility, keeping it no farther than 700 meters away. And also, we often face challenges with drone takeoff and landing due to the complex environments in which we work, such as swamps, inside dense mangrove forests, and other difficult terrains. These areas increase the risk and complexity of flights, making it harder to find suitable spots for launching and retrieving the drones. And successful operation in these conditions heavily depends on the experience and skill of the pilot, for example, as they must carefully navigate and manage these risks posed by obstacles and unstable ground, ensuring safe and efficiency data collection. And there are some products that we generate from drone data, like digital elevation models, coverage maps, photographs and videos, orthophoto mosaics, vegetation index maps for example, the mangrove forest in this example. Also, I want to show some case studies in Colombia. These studies cases are located in Ciénaga Grande de Santa Marta, in Cispatá, and in the Providence Island in the Caribbean Sea of Colombia. There are some examples. This is the monitoring mangrove cover of Ciénaga Grande de Santa Marta. This is the largest coastal wetland in the Colombian Caribbean. And this vital ecosystem supports a diverse range of flora and fauna, playing a crucial role in regional biodiversity, water filtration, and carbon sequestration. And despite its importance of this site, the Ciénaga Grande faces significant threats for pollution, deforestation, and climate change, and is need to ongoing monitoring and restoration efforts in this area. To support this monitoring, we conduct a field trip to collect preliminary information for the project using pre-classification with Sentinel image. We select points for verifying mangrove cover with drones to assess loss and gain of coverage. These results were mapped and integrated with Sentinel image, creating training points for random forest classification to generate a comprehensive mangrove cover map. In these areas, the navigation is complex, the environment is very challenging, and we often use a small boats, like you see in this one of the photographs. And we conduct the drone flight from this boat. Operating from a moving platform like a boat adds another layer of difficulty, as the pilot must manage not only the drone's stability, but also the boat's movement, making precise control essential. This method is crucial for reaching areas deep inside mangroves, swamps, or along rugged coastlines. This is another case study. For example, this is the characterization of mangrove ecosystem for restoration. In 4 different areas of operation, we conduct drones flights in Bahía Concha, Caleta de Tambor, Rincón de Múcura, and Verrugas in the Caribbean Sea. These flights generate orthophotographs and multispectral imagery, which we use to apply vegetation indices for extracting the mangrove cover and assessing the health of these mangroves. This data establishes a baseline on ongoing restoration efforts in these areas and supports long-term monitoring to track change and improve conservation strategies. And the other case study that I want to show is about the monitoring of mangrove in Providence Island. In this area, as a consequence of the recent hurricane that hit the island in the Caribbean of Colombia, INVEMAR, in collaboration with the Ministry of Environment and Sustainable Development, has initiated efforts to monitor the change in mangrove cover. This ecosystem was one of the most affected by the hurricane, with nearly all mangrove cover in the McBean Lagoon has affected. In 2023, we visit the area and conduct aerial surveys using drones to assess the current state of the mangroves in every patch. Detailed aerial photographs were taken. I'm going to show the photographs that we taken. These photographs, we can precisely accurate the mangrove that are dead and the mangrove that can be regenerate after the hit of the hurricane. And this precise imagery allows us to do that for this ecosystem. And this is, for example, other case study that is in the Boca de la Barra. And this is the only mode connecting to Ciénaga Grande de Santa Marta to the sea. To observe change in the coastline, we collect images every month to determine the change in the coastline. With the regular monitoring, we have noticed the dynamic nature of the coastline, for example, with observable change occurring monthly. This ongoing observation allows us to track and understand the coastal dynamics and their impact on the surrounding environment. And this is the last case that I want to show. This is the Atlantic Department, specifically in the town of Puerto Velero. We gathered information about the area by conducting drone flights to obtain high-resolution image. These images help us to identify seagrass patches that were previously unmapped. This work was complemented by a team of biologists who perform fieldwork to verify and map the seagrass using a grid. I want to also to comment about the benefits and challenges of using drones for monitoring, especially in this case that I tell. The benefits that we find are the high resolution data, because drones provide high resolution image and videos, enabling detailed analysis for this type of ecosystems. And also the accessibility to remote areas, because they can easily reach remote or hard to access coastal and marine areas where traditional methods may be impractical or costly. The cost efficiency, because compared to many aircrafts or satellite imagery, drones are most cost-effective option for frequent monitoring and data collection. And also the real-time data collection, because drones can deliver real-time data, which is essential for fast decision-making in response to environmental change or threats. And we identify some challenges also with the use of the drones. For example, the regulatory restrictions, because drone use is subject to aviation regulations, which can limit flight areas and operational flexibility in some regions. And the weather dependency, because drones are highly affected by weather conditions, such as strong winds, rain, or storms, which can delay or complicate the data collection efforts in the area. And the battery life, because limited flight time due to the battery constraints can reduce the covered area during a single flight and requiring multiple missions for large areas. And these are like the benefits and challenges that we identify. And I want to say thank you to you for your time and for your attention.
Thank you so much, Diana Carolina, for the nice presentation. Mark and Anna and Diana Carolina, if you can please turn on your webcams, and then we'll proceed to the Q&A part of the presentation today. It was fun to travel from the Arctic to the Caribbean regions in the space of 1 hour, so thank you for making us travel like this. We have one question from Adrian Boras. This came during a presentation, Mark. There's two parts. First part is, what difference do you make between monitoring and surveying?
Yeah, I referred to those, I think, in the introduction of the drone types. So referring to survey was on a more larger scale application, potentially also like an explorational application. And once you're identifying an area of interest and you want to monitor, so you want to have like a repeated acquisition of the area, then you can see if a big drone is required or not. But this explorational character is something I would relate to the fixed wing drones and to the surveying part, if that answered the question.
Okay. And then the other part is, how are you able to evaluate abundance of species using drones?
Yeah, I'm not quite sure if I understood the question.
Okay, so the way I understand it is, how can you evaluate how much of a given species there is in an area, the abundance?
Yeah, so normally, or it perhaps relates a bit to what Anna also presented. So normally we are trying to stitch single images to have like an overview of the entire area. And of course, there are like some assumptions and you have some limitations due to animals moving, but we are counting those animals being present on the majority of the images and therefore be visible in the stitched image. And perhaps also again with the drone footage, normally we have we have an idea on what we are looking at. So for instance, for the breeding birds, we are counting the birds, but having this digital data available also in a later point of time, you can recheck this same material and look for another species if you're interested in. So we had this year, for instance, some harbor seals lying next to the bird colony, which was quite interesting, but not the target species in this case.
And maybe for the breeding birds, there's also in Germany a slightly older publication for how they assess the number. So from what they count in the field, then assess of what is the number of breeding pairs, for example. And there's like a factor of 0.7 that you multiply this with. And we transfer this to the drone surveys. And there has also been a publication from Danish people, from a Danish university, who has been testing if this factor of calculating the breeding pairs from the number of individuals can be also transferred to drone surveys, and it was quite a good measure. But of course, there's always some uncertainty.
Okay, thank you. There's a question that came from my colleague Theo Lepierre, and this was probably more for you, Anna. What would be the percentage of error with the AI automated bird identification? Suppose you've done some comparison of manual and versus AI.
So far, from the results we have so far, we can achieve recall, like species-specific recall, of up to 99%. So it's species-specific though. So we have some species it's 85%, and some species it's 98, 99%. And in general, because we're interested in finding all the birds and classifying them also correctly, so we rather have too many detections for each type of species, and then because it's an AI supported workflow afterwards, we do like a manual check, and it's still very time efficient if you in the manual check just have to kick out the wrong detections. So that's also a way in which we can reach very good, even already, we're still working on it, but already very good species-specific recall. So finding a lot of species-specific correct birds, let's say.
So you prefer false positive versus false negative?
Yes.
But perhaps here also to add is for the breeding birds, we have quite a limited number of potential birds in the area. So compared to, for instance, like an offshore survey where you have a high number of species present, the breeding bird surveys typically have like around 10, 12 species we are discriminating. So the task is a bit easier for the AI as well.
Okay. So for the percentage of accuracy, I suppose it's dependent on the size and maybe some of the features, if there's different colors, things like this. Is that right? Or not?
I would say it's hard to tell. We have like two species which are quite similar in the size and just differentiate a bit in the coloring. And the AI was doing it quite well, even using a high amount of different light conditions and so on and so on. So like a herring gull on one image could look like a herring gull or not. But the AI is doing quite a good job. We so far haven't discriminated or really discover like a pattern on what is working best. It's also highly dependent for now, I feel, on the number of training data, which is not balanced.
Okay. Okay, we have just about 1 minute left. I want to see if there's any more questions. You can send them in the Q&A. I'll just wait a few seconds to see if anything comes up. Okay, doesn't look like it. So thank you again, Diana, Carolina, Anna, and Mark for a great session. Thank you, Mark and Anna, for putting it together, organizing the session and doing the background work. Thanks everyone who joined in. I know I learned a lot of stuff on this presentation, so want to wish you a good rest of your morning, afternoon, or evening, wherever you are. Thank you so much, and be in touch.
Thank you.
Thank you.
Bye.
Enjoy
Thank you very
the COP.
much.
Thank you.
Bye.
Bye-bye.
Bye.